Hello and welcome to part 3 of our Infectio project. In this part we're going to look at developing a spore system, so it's going to grow spores from the mold that we already have propagating across our surface. And if I hit play here we can see our particles are being infected, and I could even turn on the OpenVDB mesher. And there we go. So along with that surface I want to have these sort of hairy, furry spores coming out of the surface as well, just for an extra added level of detail. So let's, I'm actually going to rename this mold surface. And we're going to generate spores from our existing simulation, our existing particles. So let me turn off the mold surface for a second. Let's take a look at our particles. Now you'll notice there's actually some shimmering going on, and just as a side note about displaying stuff in Cinema 4D, if you see that shimmering, it usually means that the display is, the view clipping is set too low. So I'm just going to hit Control or Command D if you're on a Mac, Control D. And then if we look at the view clipping, if you now set this to large, that shimmering will actually go away. Okay, so that's an aside, and I think we could drop the size down to 100%, like so. And we can also turn off snapping. Excellent. So we can see our particles are propagating across the surface, and I don't want these spores to be anywhere that we don't have any infection, because otherwise that would look a bit weird if it just started spawning on this white surface here. So what we're going to do is we're going to use this particular group to spawn our particles. So let's start setting this up. And we're going to add a Spawn Modifier. So in the modifiers folder, I can grab from the generate modifiers section, because it's going to generate particles, the xpSpawn Modifier. I'm going to put that at the bottom of the stack there. And I'm also going to add a spawning emitter. So if I already had an emitter that I wanted to utilize as to feed the particles into to spawn them, I could just connect it up. But I'm going to add a new spawning emitter. So I'm going to hold Control down when I click this. Now, on Mac, it'll be Command, but if you do this, it means that we keep the Spawn Modifier selected, because I want to edit some settings on here. And the first one is the number of particles we're going to spawn. I only want one particle per unit time. So I'm going to say to generate one, and I'm also going to say spawn only once. This just means that once it's spawned once, it will never add another particle based on that original particle, so we don't get too overwhelmed with the particle count. Okay, so that's really the basics of the spawning that we need, and I'm also going to make sure that it's only assigned to the red group. If I left it at default, it would spawn over all the particles, even the invisible ones. So I'm going to go to Groups Affected, open up our Groups Null, and add that one in there. And then now we can jump to our spawning emitter. Put that there. Now I'm going to change the display type. I'm going to change it to something that's going to display direction. I'm going to set it to pyramid. I'm going to make sure the size is small, so only pretty small. We can give them some speed so that they move away from the surface, or at least move in a direction. And then because I've given them the pyramid display, I want the particle rotation to be assigned as well. So I'm going to go to Extended Data, Use Rotation on the General Data tab. I'm going to set it to tangential. Okay, so there's a bit of setup there. Let's test it out. So I'm going to hit play, and we'll see something's happening, but our particles seem to be behaving quite strangely. First of all, they've got a strange color, and also they seem to be sort of becoming infected and dying off, and all sorts of weird stuff going on. Now, what's happening is all the modifiers in this system are affecting our emitter here. So if we go to the modifiers tab, we can see that it's automatically added an exclude for its own xpSpawn. That's normal. But in reality, it's not excluding all of these other modifiers. So things like the kill, the color, and the Infectio. The Infectio is probably the thing that's going to be causing it the most chaos. So what I'm going to do is I'm actually just going to keep it simple. I'm going to change the mode in this modifiers section to include, and this is the modifiers I want it to include, and of course it needs to exclude that spawn modifier. So now the spawn modifier is going to generate particles to this emitter, but it's not going to let them be affected by these other things. And there we go. We can see our particles moving off. And we're getting a big cluster of them. And that's looking pretty cool, but not quite what we want in terms of size. Their radius is huge. So let's set their radius to a much smaller size. So let's go for like 0.1. And there we go. Starting to get a lot more detailed look going on. And that's starting to look really cool. And they're moving away from their source particles. And that really is the core setup of our spawning system, of our spores generation system. Let's deal with the actual direction and give them more control of how they move away from this surface. Because currently they're moving in a random direction, and that was set by the xpSpawn. If we go in here, we see set to random spherical. If we go underneath and have a look under, you'll see that they're being moved under the surface, and that's undesirable. So what we're going to do is we're actually going to utilize something called the xpFlowField, and that's going to utilize the geometry to give the particles direction to move away from the surface. And we can do this. This is where we can break out our new XP system object. So currently we can get confused between these two systems if we're not careful. We could absolutely set up our spores to generate in just this one hierarchy, this one system. But I like to keep things tidy, so I'm going to add another XP system object. Let's clear out the default emitter that it adds. And let's jump up here and let's rename this spores. And let's also change the color. Let's give it a nice contrasting color. And then I'm going to drag our emitter that's being controlled by the Spawn Modifier. I'm going to rename that one spores as well. Let's give it a different color as well. Let's go for something that contrasts that original emitter down here. And it's also a good practice to add a group as well, because you can often work with groups to isolate things. So I'm just going to create and add a group. Spore group. And then I'm going to make sure that our xpSpawn modifier is feeding that group. So I just drag it down into this group option here. There we go. And I've just noticed the spawn number timing, if I press play, we get it's set per second. So you get this sort of stepping. So every second, it'll actually generate the particles. We want it to be spawn timing set to per frame. And there we go. And you can see the system is looking exactly the same as it was before, except this time the spores are isolated in their own system. So if I just, let's put that after the slime mold, just execution order. The look is exactly the same, and that's because we had our emitter set to ignore all the modifiers in that other system anyway, because we had it in include mode, but I can put it back to default. However, now we're in a unique system for each of these. The only modifiers in the same system active means that we can isolate our spores. Once they've been generated by the xpSpawn modifier, they are now isolated and we can work on them separately without worrying about affecting our original simulation. So now we're going to look at controlling the initial direction of the particles. And we're going to make them move away from the surface using an xpFlowField. And we can add one of those from the Dynamics folder here. Choose Dynamics, and then it's the xpFlowField. Add that to our scene, and you'll see we get a yellow bounds. In fact, we're actually seeing two yellow bounds. One is our kill modifier. Let's hide that up here, and then minimize again. So now we're just looking at our flow field. We could also turn the texture off of the skull just to keep things nice and clear. If we go to options at the top of our viewport, turn our textures off. There we go. So we can see our geometry a bit clearer, because that's going to become important in a second. So we've got these cells, and you can see they've got an arrow. Each of them has its own arrow, and that is a vector direction. So at the moment, it's set to, well, the default is set to direction, but you can also set velocities, and we'll do that in a second. But now we can just think of these as an individual voxel, an individual cell that has a direction, and then depending on this strength value, and if it's got the fall off value as well, the particle will enter that cell and be given that direction. And if it's a high strength value, it'll assume that direction very quickly. It'll blend that direction from its own the direction before it enters. So if I put it to something a bit more interesting looking, let's set it to a random direction and press play. When our particles are emitted and they're moving along like so, you can see that they are being given a random direction. It looks quite like a turbulence, in fact, at this point. And if I made this more extreme, they would assume the angle's much quicker. So you can see they're moving away, they're following these arrows, and as they move into another cell with a different direction, it'll move away. And we actually end up with something a little bit like a curl noise. But we don't want to use this random, we want to actually utilize the geometry. So before I do that, let's position our flow field a little bit better. Currently it's set to a bit too large, and we'd be wasting the voxel space down here, the cell space down here. So I'm just going to lift it up above the surface, and I'm going to make sure it's shrunk down in size quite a lot. Let's do only 200 or so high. Let's make sure it's rotated as well, so it can kind of face along. And I might actually just turn that texture back on so that I can see when I'm lining this up, make sure it's covering that whole zone. So just rotate it a bit more and then bring it in fairly tight to the edge there. Center it up on the skull. There we go. I can bring it forward as well so that it's sat nicely there. Probably moved it too far to the right there. Definitely. There we go. Okay, and the density of the flow field is currently fairly low, but I'm just going to leave it at that level whilst we're setting things up. So grab the flow field again, and I'm going to change the mode from random to surface normal. So set it to surface normal, and then we can drag, or we can use the picker to grab our connect, and you'll see all of a sudden the flow field changes, and we get these arrows facing away from the surface normal. So, or along the surface normal, I should say. So if we actually go into the connect object, we go into poly mode, and we go to the options, and we view our polygon normals. I've got it active already, but you can just find it up here. So polygon normals, and then we just select them all. You can see that this is what the flow field is looking at. It's averaging these polygon normals if they're inside a cell. Then it takes the average of that and then assumes it creates the direction vector from that. And depending on how dense your flow field is, let me just unselect that stuff. And let's go back to the no texture view. There we go. Now it assumes that direction, and the cell size means that it's kind of an approximation at this point. It's like a resolution, you can think of it. So the lower the cell size, the higher accuracy the flow field will be. And we definitely want it more accurate than it is right now. But I just want to set the display up. So I'm going to go to the display tab, and I'm going to uncheck direction only. And what that means is, if I go back to the general tab, that means that we actually have the strength as well. So the fall off is the distance from that surface, and it's multiplying down the strength of that vector, the magnitude of that vector as it moves away. And displaying the direction only means that we see ones that are zero strength, or giving it zero value. Okay, so now let's actually change the mode of our field to velocity. And if I press play with velocity active, it's going to push our particles away really fast and aggressively. So we want to drop that right down to 10 units. And there we go. And you can see they are moving away from the surface. And it's all automated because there we go. It's all based off the topology of that geometry. So at the moment, like I said, it's very low resolution. So let's increase our cell size, increase our cell number and decrease the cell size. I'm going to go for 10 units. So that's going to be quite a fine, you can see that's a pretty fine flow field. Now you can see it affects the viewport performance when you're viewing these arrows. So I'm just going to hit the display tab. I'm going to leave the bounds. So I want us to be able to see the bounds, but I'm going to turn the vectors off. So that just means that it cleans up our view since we're done diagnosing that stuff. And now we can just rely on that. And you can see now we get this nice motion away from the surface. All right. Now we've dealt with the initial direction of the particles, and I want to add a couple of modifiers that are going to dictate their motion once they've moved away from that surface a bit. So one of them is going to be a direction modifier, because I want the particles to have a generally upward direction. Imagine we're on Earth, away from the center of the Earth, so it's against gravity. And that's how a lot of plants and fungus grow. They, even if there's no light, they grow away from gravity. So essentially, they'll grow upwards. So what I'm going to do is I'm actually going to add a direction modifier. So it's a motion modifier. And I'm going to add it here, a direction modifier. And if I just move that over here so we can see the arrow, it's currently facing along Z. And if I increase our acuteness of turn, you'll see that it pushes our particles along with the flow field. It's working with the flow field. So the flow field pushes them away from the surface at the beginning, and then our particles get pushed along Z there by our direction modifier. So of course we want it to go upwards. So let's increase our pitch. You'll see the arrow points upwards. And then I also want to make sure that they have a bit of variation. I don't want them to all go directly upwards. So I'm going to give them a variation of 10 around that 90 degrees. And there we go. Now to see this really clearly, to see this motion, the path that they've traveled, it would be a good time now to actually add in our trail object, which is going to form the tail, the hair, sort of the stem of our spore. So if I jump to our emitter, whilst I have that selected, I'm going to go into my commander and I'm going to add an xpTrail object. Now this will add to our scene, and I can put it in our generators group. Go back to the beginning. And there's a couple of things I want to do. Well, there's one thing I want to do mostly, and that's go to the thickness and color tab. And then I'm going to tell it to not store or calculate any of the thickness and color data, because by default, the trail object stores that data, and it's useful for when you're rendering and you need that data to be stored. However, we don't, so we're going to dictate the color of those later on render time. So I'm just going to click that off. That'll just improve performance. And then I'm going to hit play, and we'll see our trails generating. And you can see, because I've got them selected, they're white. And there you go. So you're starting to get an idea of what we're going for here. Now the density of these spores is way too high at the moment. And that's actually what we should deal with next. And I'm going to reduce the number of them down. And what's dictating their number is the actual original spawn, xpSpawn. And if we jump, let's minimize this hierarchy and open up our spline mold. We look at our xpSpawn, and we go down here, we can see the spawn number is 1, so 1 per frame, and it's generating off each of the particles, each of the red group particles. So and it only does so once. So we're getting 1 per red group particle. And that's just too dense at the moment. So what we're going to do is we're actually going to control the spawning via a questions and actions setup. And if we jump to our mold emitter and click on it, and then we go to the questions tab, I'm going to add a question. So you can add the question here. You can also do it the other way around. You can actually add the question into the scene and then drag it into here. So you don't have to use this method, but I like this one. So add a question, it's connected it up. So if I go back to my emitter, you'll see that it's in the test and pass only once, and jump down here. Now the default is age, so it's going to test the particle age. I don't want it to test age. I want it actually to test a probability. So I don't want as many of these. So I want the spawning to only have a low chance of spawning. So what I'm going to do, so I'm going to change it from looking at the particle data to question to other kinds of data. And the other kinds of data is going to be random probability. So currently it's set to 100% probability, and we would see no difference here at all. But if I set it to 1%, and I connect this up to drive our xpSpawn, so I'm going to say, if I just minimize these a bit, modifiers to activate. So what I'm going to do is I'm going to activate the Spawn Modifier if the 1% probability is met. So if the test looks at all the particles and it goes 1% of these particles are going to spawn another particle. So let's set that up, and you'll see the icon of the xpSpawn has changed from solid green to green and half blue. That means it's now an action controlled modifier. All right, so let's test this out. So let's go back to the beginning. We should see a lot less particles, and it's a lot less dense. And there we go. So this is a good way of controlling the amount of particles that are going to become the spores. Okay, and we can actually add other questions to this. So we can have not just the single probability question. It's like, 1% chance that it's going to spawn. We can add another question that it needs to fulfill to continue spawning as well. So what we do is we actually grab the random probability question, and in that question object, you can see we have this section here, and I'll just minimize the other stuff. Sub questions. So a sub question is exactly what we just described. If I add create sub question, it's going to add a child to this random probability, and it's called particle age, and that's actually the one we're going to utilize. So let me just drop that down to 30. So if we think about the operation that's going on here, the question that is occurring, it is essentially every time it's being tested, it's saying, okay, there's a random probability that the particles are going to spawn at this rate, and the rate is at 1%. So 1% of these particles are going to spawn, and they also have to be of a certain age. And currently it's set to greater than 30. So you'll see at the beginning we actually got no particles spawning at all until we reach that 30 in age of the particles, and they start growing. Now, I actually want to do this the other way round, in the sense that I want this to be less than. So I want to make sure that the particles, only the youngest particles below the age of 30 can spawn any spores. So there we go. That just means that as they grow older, the particles will no longer be included, and we don't get over dense in the simulation. Okay, so that's a way of controlling the number of particles and the number of spores. And I'm wanting now to develop the motion again, and so we'll jump back into the spores hierarchy, and let's add a turbulence, because these are currently too straight. Let's add a motion modifier, a turbulence. Now, we want the turbulence to be pretty fine, and so we'll drop the scale right down. So we'll drop the scale, we'll drop it right down to 3%, and then the strength to 10. And let's press play. And this should give us a nice fine extra motion. There we go. Now, if that scale was too high, it would look quite soft, this randomization here. That's looking really nice. Excellent. Okay, so this really is the most of our setup is ready to go. I do want to tweak the amount of when the turbulence kicks in and when the direction kicks in. So I want to let them sort of move away from the surface a bit before any of these kick in. And we can do that using mapping. So if we select for instance, let's start with the direction, go to the mapping tab, and we're going to add a map. I'm going to leave it at the default curve, but I'm going to change the parameter that it's driving. So if I hold shift down, I can view my object tab at the same time. And the parameter I want to drive is the acuteness of turn. We can think of that like as strength. So currently the parameter that we're going to map is heading. We don't want that. We want to change it to acuteness of turn. And then we don't want to map to age. I'm actually going to map to distance traveled. So that data is stored in the particle, and then it's checked. It's mapped. So distance traveled, and I'm going to set it to a low value. In fact, what I tend to do is that if I want to know what range to use, I need to kind of get a reference point so I know how far the particles have traveled. I will actually grab a guide tool to be able to see and measure that. So let's just do that quickly. Let's grab a guide tool. So guide tool. It's in the model menu. And I'm actually going to put the snapping on. So if I enable snapping and then I make sure it's on polygon snap, it is. There we are. Activate the guide tool. When I now drag away from this surface, you can see I can get a guide that comes off this surface, and that allows me to see how far a certain amount is. So you can see here, and I could change this. So that's 4 units, 3 units, and this is something that doesn't get rendered, so it's useful as it's a bit like a null, you know, but a measuring tool. So I'm actually going to do it at, I just want it to kick in after it's traveled about 3 units. So let's delete that guide and go back to our XP direction modifier, and let's change the maximum range to 3. So basically over this curve, the range starts at 0. So the 0 value will basically mean that the particle strength, the modifier strength will be at 0. And then as it gradually moves away from the surface, as it moves along, it will increase until it gets to that maximum value of 60%. So we can check this out. And it'll just basically mean that the direction is going to kick in later. So you can see that curve. Get that nice curve away from the surface, and then the direction kicks in. So just a nice way of easing in modifiers. So we'll actually do exactly the same on the turbulence. So we can just jump to the turbulence mod, add a map, and I want to drive, if I jump to the object tab, I want to drive the strength of our turbulence. So strength, change this to distance traveled, and 3 units. Like so. And there we go. We don't have any turbulence at the beginning. We don't have any direction being forced on it. And then eventually it gradually eases in, you know, as the spore, imagine it detecting that direction. Okay. So now we've got the direction sorted out and all that stuff. We are currently not letting the particles stop, or we're not stopping the particles in any way. They are just carrying on moving. So they've got no impetus to slow down or anything like that. And in fact, that one's escaping a little bit too fast over there, but that's fine. And what we'll do is we'll add an XP speed modifier. So go to our modifiers here, modifiers folder, and it's a motion modifier. So it's XP speed. And then I'll leave it there, and then we'll go to the object tab. And I'm going to change it from incremental, which would just increase the speed or decrease the speed per calculation, whereas this I'm going to use acceleration, because I'm going to actually decelerate the particles. So we're going to need quite a strong deceleration. Let's press play and you'll see our particles are not going to move nearly as far away from the surface. And I'm definitely going to map this one on as well. So we'll have this only kick in sort of later on. And you can see it's even at that high value of 200, the deceleration is still being fought against by the other mods. But they are kind of coming to a slow. I think I'm going to set this to 500. And that should bring them to pretty much to a halt in a timely fashion. There we go. Nice and slow. Okay, so let's add that map to the speed modifier. So let's add map. And I'm going to set it to distance traveled again. This time I'm going to go a little lower than that 3 value, and I'm going to go for 2.5, so it kicks in a bit earlier. And then it's driving the parameter, it's mapping the parameter exponential. So let's just go to the object tab, and it's going to multiply this negative 500. So let's try that again, this time with the map. And we should still got that nice curve, but they will slow down. And when they get to a certain speed, I'm going to want them to stop completely. And what we can do, we can actually use a question to actually dictate that. And also we should have our speed modifier at the bottom of the modifier stack, so it's the last thing that occurs. And there we go, where we can see our particles are coming to almost a complete stop. We can enforce that by adding a question into our emitter, so that when they are below a certain threshold of speed, we can permanently freeze the particle. So we'll do that by going into the emitter, And of course, we need to add a question. So it's the questions tab, just like before, add the question. And the default one, of course, is particle age. I want to change that to the speed. And I'm basically looking for the particles to go below a threshold of speed before they're completely deactivated. And if I say is less than, and then is less than 3 units per second, so if it's moving less than 3 units per second, do something. Now I'm going to add an action for this. So in the question object itself, you can add the associated action and it'll automatically assign it to that question. And to start with, we'll just debug it by viewing the editor display. So press play. Now, once these reach a certain threshold, they should change to a white cube. And you can see some of them are actually changing. And we can increase the size of these particles to make it a bit clearer, but let's just zoom in. And you can see once those have reduced down at a certain speed, they are changing their display type. However, we don't just want it to change the display type. We want it to stop the particle. We want it to freeze the particle. So I'm going to change our action here from the action type other actions to a direct action. We're going to drive something very directly instead of activating a modifier or anything like that. And we're going to go for the freeze particles. We're going to set speed to 0 as well. And we're going to play again. And now when they grow and they move now, when they get below that 3 units per second threshold, when the speed mod has dropped them below that, they will actually start to freeze completely. And you can see there, we're getting them in their frozen positions. Excellent. And the rate at which that happens, of course, is dependent on how quickly we slow those down or how high that threshold value is. But I'm happy with those as they are, and we can now move on to the scale of the particles. So let's create a new modifier, but also let's organize these. And these are the modifiers that are dealing with motion. So I'm just going to call this motion, create a subfolder. I'm just going to put all of those in that, and then I'm just going to fold that just to keep things nice and tidy. They're still active, they're just folded away. And go back to the modifiers null here, and let's add a scale modifier. So this is actually a control modifier, because it's going to control our scale of our particles. Let's put that at the bottom there. Now, if I just leave this at the default and I press play, you'll see our particles expand up very fast, very rapidly. And then they reach an upper radius limit here of 20. But they are freezing and changing their color there. I'm going to change the display type back to circle, actually, so that we can see a closer approximation of what they will look like eventually. So in the spore group, I'm going to change the pyramid to a circle and also make sure that the freeze particles action changes them to circles. I'm going to change them to yellow circles, actually, because they are going to be yellow like the surface when we're done. So let's press play, and you can see them. They're a bit like bubbles, expanding all the way up until they freeze. Go that yellow color. So they're getting to a much higher radius than I want them to. So let's drop the upper radius limit right down. Now if I do it, they'll look like they're popping on because the maximum radius is so close to this radius change value that they're instantly at that value. We also need to ensure that the initial radius of our particles is 0. Otherwise, we're not scaling up from 0. So let's just jump to the spore group. And currently they're set to 0.1. Let's set them to 0. Let's go back to the beginning, go back to the scale. And I'm going to drop this radius change rate value to something very low, 0.01 units per second. And then I'm going to give it a touch of variation as it's growing. Then I'm going to hit play. And we should see a nice, gentle grow up there. And that's definitely looking much nicer. And they're turning yellow as they freeze, of course. And we're kind of getting a good idea of what the final sim is going to look like. In fact, let's turn on our mesh, our OVDB mesh, so that we can see what that looks like under the hood. There we go. So that's looking really cool. Now the particles are reaching a sort of a maximum radius of that 0.5 units. Let's turn that mesh back off. If I jump down here, that upper radius is a consistent radius. So if the particles are moving for long enough before they get frozen, because the scale and all that is frozen as well, if they are moving far enough, they will reach this upper 0.5 radius. So they'll all be exactly the same size. Now that's not a problem for us because we're going to be rendering and we're going to utilize the cycles instance tag, which will allow us to add random variation in the size of the particles later on. But if you did want to add a randomization to this upper radius limit, you would just do that via the mapping tab. So you'd add a map and then go for a shader. But we don't need to worry about that because we're doing that on render time. And let's just zoom out. And that's looking really cool. So this is actually ready to cache now. So let's go back to frame 0 here. Let's add a cache to our scene. Now we want to cache everything at the same time. So I'm going to add an xpCache object. And I'm not going to have it sit in one or the other of the systems. And we could cache the system separately, but I want to cache everything all at once. So I'm going to rename this. Let's call this cache global. And we're going to include everything in this cache. So if you go to the inclusion tab, it just shows you that by default, it'll include all of these things. We're going to cache the full timeline. And other things to note are that you should be careful about how you name your XP items. They should have unique names, otherwise the cache won't be able to cache. Things like this trail object, we don't actually need to add, but it's good practice. Let's name that spores as well. And let's just check in our slime mold and activate our mold surface. And what we're going to do is we're going to hit build cache. And when we come back, we'll review the cache and then prepare the scene for the rendering stage. So let's hit build cache. And there we go, that's building. And I'll return once that's finished. So I'll see you then. All right, so that's cached out, and I can now play back our simulation. I can even scrub our simulation now because it's cached down to disk and it's just loading that data in. That's looking really nice. We've got our mesh, our OpenVDB mesh has been cached, and our spore particles with their trails as well. It's looking really cool. Now, if I play, the playback is going to be slow because it's loading in a lot of data, and mostly it's the Cinema 4D struggling to display that data. And what happens is it slows down and we get a low FPS. Our playback speed is really low. So what we can do is we can actually, if we jump into this button in the bottom right of our animation palette, we have this all frames option. Now, if I uncheck that, what that means is Cinema will disregard having to display the frame and having to calculate everything for that frame to display before moving on to the next frame. So it's maintaining the playback FPS at the sacrifice of whatever needed to complete before that. Now, because we've got these cached down to disk, it doesn't matter. However, if you were just simulating, it means that you would jump frames and you would end up getting a very inaccurate and odd behavior of the particles and stuff like that. But that's one way to get a rough idea of the playback. Of course, the only way to really know is to go to a hardware preview or to render. But that's looking really nice. Okay, so let's just do our final preparations before we go to the render part. And we're currently viewing the connect here, which is the collision geometry. I'm actually going to deactivate this and I'm going to hide it from our scene. I'm also going to turn off that icon for that one there. There we go. And let's activate our scene geometry. So let's just unhide that stuff, unhide that. And there we go. So we're now seeing our actual skull and ground geometry. And there we go. So that's looking really nice. I also want to extend the timeline in preparation for rendering because I want cameras to go beyond the point at which the animation is completed when it's made this nice logo. So I'm going to extend the timeline by to 600 frames. And then also in the cache, I'm going to ensure that we have the hold in the playback parameter checked on. And what this means is that at the end of the Once it gets to the end of the cache, it'll hold on the last cached frame. If I didn't have this on, xParticles would attempt to continue simulating the particles. And obviously that's not going to be practical. We just want them to stop. And now it's frozen on that last frame. So it's just like a hold frame in After Effects or Premiere. Alright, so our scene is now ready to move on to the rendering stage, and that's exactly what we're going to be doing in the next part. We're going to be developing materials for our mold surface and also creating geometry for our spores and giving them some variation in their scale. So I'll see you in the next part.